Write the equations of all of the asymptotes associated with the rational function y equals f of x equals 4x squared minus 7 divided by x times x minus 3. Now, what makes this a rational function is that the numerator is a polynomial and the denominator is a polynomial. If you want to see that a little more explicitly, the numerator can be just left alone. That's clearly a second-order polynomial. And then the denominator can get multiplied out. When you multiply x times x minus 3, you get x squared minus 3x, and now that too looks like a second-order polynomial. Both the numerator and the denominator have no factors in common, so the first step is to equate the denominator, either this way or this way, but the easier way is over here. Take that denominator and set it equal to 0. We know that we cannot divide by 0, so these two values that we're going to get right here are going to correspond to vertical asymptotes. In this case, we have one thing multiplied by another thing is equal to 0. Again, we're trying to find out when the denominator is equal to 0, and that means either the first is equal to 0 or the second, which is x minus 3, is equal to 0. Now, this first equation is already solved for x. To solve this equation for x, we add 3 to both sides of the equation. When you add 3 to the left-hand side of the equation, you get x. When you add 3 to the right-hand side of the equation, you get 3. So at x equals 0 and x equals 3, you have vertical asymptotes. Now, the next thing you do is, because the degree of the polynomial in the numerator matches the degree of the polynomial in the denominator, that is, they're both second-order polynomials, the ratio of their coefficients, that is 4 to 1, gives us a horizontal asymptote. So we will have a horizontal asymptote at y equals 4. So when we are drawing a graph of this particular rational function, it is important to start by drawing these asymptotes. So for example, if this is 3 units in this direction, and we'll label 4 in this direction. So when you are graphing this function, one of the first steps here will be to go ahead and draw in the vertical asymptote that is at x equals 3. And that vertical asymptote will look something like this. And then draw in the vertical asymptote at x equals 0. Well, x equals 0 is just the y-axis, so that is right on top of the y-axis. That is also a vertical asymptote. And those asymptotes, of course, are to indicate that you cannot divide by 0. At x equals 0, which is along here, you'd be dividing by 0. At x equals 3, you would be dividing by 0, and you can't do either of those. Finally, you would want to draw in a horizontal asymptote at y equals 4, and that would look something like this. Keep in mind that as you're graphing this rational function, you would now start plotting points, but keep in mind that in the limiting cases, the graph of this rational function will approach the asymptotes.